has been playing organs since he was 10 years old. Today he's playing his favourite one in the minor Basilica of St Andrew, around 60 kilometres east of Krakow in Poland. It's also one of the oldest of its kind in the country, having been in use since 1611. The signs of ageing are starting to show. Here Yaroslav's playing a Renaissance period piece written especially for the instrument.
This organ is a witness to history. Through it we know with a good degree of precision what kind of sound was made during the Renaissance and Baroque periods. We don't have much written documentation of that particular time, but a trained organist can figure out what the music was like back then just by following a musical score, playing it on the keyboard and taking full advantage of the sounds provided by the pipes. Preserving instruments like this is very important for our national cultural heritage.
Więc to najbardziej chyba oddaje brzmienie z epoki.
This, like Poland's 4,000 or so other historical organs, is at risk. Its complex internal structure, a labyrinth of wood, iron, lead and tin, is very sensible to any changes in its climatic surroundings. That's why physicist Łukasz Brates makes monthly trips into its belly. Special sensors and sophisticated computer software allow him to monitor microacoustic emissions from cracks in the wooden structure. Cracking is a problem for an organ. Too much fractured wood and its bellows will mellow and its wind will stop whistling.
The main risk for wooden parts of organs is the fluctuation, sudden changes in microenvironment of the organs. When the temperature goes up during the heating episode, during the service, the relative humidity goes down, and this causes the stress and possibly the cracking of the wooden parts.
In the winter, human activity during a service can see the temperature rise from 0 to 20 degrees. Łukasz diagnoses this particular specimen as quite healthy, but says its progress needs to be monitored.
We are interested in this kind of the sensor, the acoustic emission sensor, which directly monitor the cracks development in the materials. First is because we can establish the tolerable range of fluctuation which are not dangerous for objects, and the second reason is we can develop the early monitoring system which will give us information about the stresses developed in the object.
Łukasz's data is analysed here at a nearby Polish Academy of Science Institute. The centre's one of 7 partners in the European programme Sensorgan, which seeks to understand better how indoor climatic environments are affecting Europe's tens of thousands of organs. How, for example, wood reacts to sudden changes in temperature and relative humidity. Laser mapping helps researchers examine cracks and prevent damage to wooden artwork, artifacts and the little things like picture frames. Roman Kozlowski is the director of the Cultural Heritage Research Unit at the Institute.
What is very important is how quickly the change is occurring. We know that if we adapt an object from one conditions to other conditions in a very slow, stepwise way, nothing will happen. But if we change the condition very quickly, because, for instance, our air conditioning system in the museum fails, then terrible things can happen to wood because the change is happening so quick.
Drastic variations in temperature and humidity are much more damaging if the material is directly exposed to the elements. We are now in Telch, one of the Czech Republic's architectural wonders, a medieval town and UNESCO World Heritage Site. Its Gothic heart has survived 5 centuries of wars, fires, floods, and anything else that man or Mother Nature has thrown at it. But it bears the scars. Some of these badly bruised facades were restored just 3 years ago. Civil engineers Milos Drudracci and Irji Blaha took us on a tour to the top of the tower of the 14th century church of Saint-Jacques. At 53 meters, the tower dominates the Telch skyline. Its stones are showing signs of stress and fatigue. two big chunks have already fallen off, and more cracks are beginning to spread. Piergi says there's a dangerous combination of materials.
Iron was used for these railings and massive but porous stones for the paving. They're stuck together in a place directly exposed to the rain, snow and wind, and subject to remarkable temperature changes. So the iron is rusting, gaining volume, and in so doing, cracking the stone and weakening the monument.
Vlivem rzy a teplotní roztažnosti toho železa.
Piergi and his colleagues have taken part in a European programme called Noah's Ark, which looks to forecast the effects of global warming on European heritage in the medium and long term. The predictions are gloomy. More and more rain will leak into porous stones. Increased humidity will cause fungi and bacteria to spread over building fronts and roofs. Researchers at the Institute of Theoretical and Applied Mechanics in Prague have been using wooden models of complex structures to test a building's response to heavy wind and rain. They also test the resistance of different types of stone from historical buildings. Considered too dangerous, these two large ornaments were removed from a 14th century church in central Bohemia. The semi-porous limestone pieces are now used to test water absorption and find out how and to what extent humidity and water damage stones. This, they hope, will lead them to better preventative measures. For Milos, one such step is constant monitoring.
All surfaces which are very vulnerable to climate effects should be discovered and detailing improved, especially the horizontal surfaces and some places where water can accumulate and can create some conditions for biodegradation. When we fix all those shape effects, we can use some protective measures to protect the surface from water, because the water in all forms is the most dangerous climatic effect.
A wall made from a similar stone at Prague Castle is now being carefully restored. But our cultural heritage sites should be allowed to grow old gracefully without too much cosmetic surgery, say many experts. That's why monitoring and prevention comes before restoration, whether it be for a simple church organ or a grand Gothic cathedral.